The meticulous planning for Operation Overlord, the D-Day invasion of June 1944, encompassed every conceivable challenge of amphibious warfare. Allied strategists considered the fierce German resistance, the treacherous channel crossing, and the brutal fighting for every inch of the Normandy coastline. Yet, even as soldiers were trained and equipment amassed, there was one fundamental vulnerability that haunted the minds of both Allied planners and, ironically, brought immense confidence to the German High Command. This was the inescapable truth of logistics: how to supply an invasion force of millions of men, tens of thousands of vehicles, and millions of tons of material across an open beach, without access to captured, deep-water ports. For centuries, military doctrine dictated that any large-scale overseas invasion simply required a functioning deep-water port. Without it, the vast quantities of supplies needed to sustain an army, fuel, ammunition, food, medical supplies, spare parts, could not be efficiently unloaded from cargo ships. The Normandy beaches, while strategically chosen for surprise and access to inland routes, notably lacked such facilities. The vital ports of Cherbourg and Le Havre, situated on either flank of the invasion zone, were heavily fortified and expected to be defended to the last man. Even if captured, German demolition teams were meticulously prepared to destroy their docks, cranes, and harbor facilities, rendering them useless for weeks, if not months. This seemingly insurmountable logistical obstacle became a cornerstone of German strategic thinking. Hitler and his top generals were keenly aware of the Allies' dependence on an uninterrupted flow of supplies. They correctly deduced that without secure, operational ports, the invading armies would quickly become starved of vital resources. Their advance would falter, their momentum would die, and they would be pinned to the vulnerable beachheads, ripe for a decisive counterattack. In their eyes, the very geography of the invasion provided an unshakable defense mechanism, a fatal flaw that guaranteed the ultimate failure of the D-Day landings. They believed that even if the Allies got ashore, they could never achieve a decisive breakout or a deep penetration into France. This conviction bred a dangerous overconfidence within the Axis command. They focused their defensive efforts on fortifying the coastal defenses and preparing mobile reserves for counterattacks, certain that time would be on their side. They saw the lack of ports not as a challenge the Allies might overcome, but as a fundamental, unavoidable limitation that would doom the invasion to a slow, agonizing defeat. Their analyses repeatedly concluded that the sustained logistical burden was simply impossible. However, unknown to Hitler and his intelligence services, the Allies were already working on a solution so audacious, so unprecedented, that it defied conventional military and engineering wisdom. This wasn't a secret weapon in the traditional sense, but an industrial and engineering marvel born of necessity, shrouded in intense secrecy, and designed to literally reshape the battlefield. Instead of capturing ports, the Allies were building their own. These were Mulberry harbors, entire prefabricated, portable ports, engineered to be towed across the English Channel and assembled off the Normandy coast, turning an open beach into a bustling harbor almost overnight. This was the ultimate response to Germany's fatal flaw, an unseen marvel that would ensure the lifeline of D-Day, and, ultimately, the liberation of Europe. For centuries, the logistical challenges of supporting an army overseas had dictated the very nature of military strategy. The iron law of logistics was clear: sustained offensive operations against a continental power, launched from an island nation, were impossible without secure, deep-water ports. These were the essential arteries for the vast flow of supplies, ammunition, food, water, medical equipment, and above all, fuel, that kept an army fighting and moving. History offered ample evidence to support this immutable truth. Even in previous conflicts, amphibious landings were often followed by desperate scrambles to capture and repair existing port facilities. Campaigns like Gallipoli in World War I had vividly demonstrated the catastrophic consequences of failing to secure adequate port infrastructure. Armies attempting to rely solely on beach landings for extended periods quickly became bogged down, their supply lines stretched thin and vulnerable, their forces unable to maintain offensive momentum. The primitive beach logistical methods of the past simply could not handle the tonnage required for a truly modern, mechanized force. By World War II, the scale of military consumption had exploded. Every soldier might require a few pounds of supplies daily, but a tank consumed hundreds of gallons of fuel, and an entire division, with its accompanying vehicles and artillery, could demand thousands of tons of material per day. Unloading this colossal volume directly onto open beaches was a slow, arduous, and immensely risky endeavor. Supplies would have to be transferred from large cargo ships to smaller landing craft, then ferried to shore, often through difficult surf and under enemy fire. Once on the beach, they would accumulate in vulnerable dumps, exposed to air attack and the vagaries of weather, before being painstakingly moved inland. Even in ideal conditions, this process was inefficient and limited. In a combat zone, it was a recipe for disaster. This historical and logistical reality formed the bedrock of German defensive strategy along the Atlantic Wall. German intelligence meticulously studied Allied capabilities and, critically, their vulnerabilities. Their analysis concluded, with absolute certainty, that any cross-channel invasion was utterly dependent on the rapid capture and full operational use of major channel ports. They knew the Normandy coast lacked such facilities naturally. Therefore, the heavily fortified ports like Cherbourg, Le Havre, and Brest became linchpins in their defensive planning. These were to be held at all costs, or, failing that, utterly destroyed. German demolition teams were specially trained and equipped for this grim task. Every dock, every crane, every warehouse, every rail line within these port complexes was rigged with explosives, ready to be detonated at the moment of retreat. Harbors were to be blocked with sunken ships and mines, rendering them unusable for months. Their confidence was not misplaced. Allied planners themselves fully anticipated these demolitions and the lengthy repair times. Hitler himself often reiterated this conviction. He firmly believed that the Allies, even if they managed a landing, would be unable to sustain a breakout due to their soft underbelly of logistics. He saw the English Channel as a formidable barrier, not just geographically, but logistically. Without the lifeblood of continuous port supply, he reasoned, the Allied armies would wither on the vine, pinned down and eventually destroyed by his counterattacking reserves. This belief deeply influenced his directives, often leading him to hold back vital armored divisions, expecting the main Allied effort to come elsewhere, or simply confident that the logistical iron law would inevitably crush any beachhead. This profound strategic oversight, born from a correct understanding of a traditional military problem but a catastrophic underestimation of Allied ingenuity, would prove to be a fatal flaw in his seemingly impregnable defense. Faced with the undeniable and crippling reality of port dependency, Allied planners found themselves trapped between a rock and a hard place. The strategic necessity of invading Western Europe was paramount, yet the logistical impossibility of sustaining such an invasion without ports seemed to be an insurmountable barrier. Conventional thinking offered no viable solutions. The immense resources and manpower required to repair a demolished port would consume months, precious time during which the Allied armies would be dangerously exposed and immobile. A radical, unconventional solution was not merely desired, it was absolutely essential. The spark of this revolutionary idea is often attributed to Winston Churchill himself. With his characteristic flair for bold, imaginative solutions, Churchill, as early as 1942, pondered the problem of port access. In a now famous memorandum to his military chiefs, he wrote, "They must be bays as we want. The only difference is that they are at the wrong end of the channel. Let us make our own ports." He further elaborated with a vivid image, "They must float up and down with the tide. The sooner you can tell me they are building, the better." This seemingly fantastical directive, to simply build ports and bring them with the invasion, set in motion one of the most ambitious engineering projects of the entire war. The concept was simple in its audacity. If you couldn't capture a port, and you couldn't quickly repair a demolished one, then you would construct an entire artificial harbor, prefabricate it, and transport it across the channel. These instant ports would then be assembled off the invasion beaches, providing the deep-water docking and offloading facilities absolutely vital for sustaining the invasion force. The project was given the innocent-sounding code name Mulberry Harbors, a name chosen specifically to give no clue to its true, monumental purpose. The engineering challenges were staggering, pushing the boundaries of what was considered achievable in wartime construction. This wasn't about building a few floating pontoons, it was about creating complex maritime infrastructure on an industrial scale. The core components of these artificial harbors had to be designed to withstand the immense forces of the open channel, including unpredictable weather, tides, and potential enemy attacks during transit. Be modular and prefabricated, allowing for rapid construction across numerous sites, then efficient towing and assembly on site. Provide stable offloading platforms, capable of handling hundreds of thousands of tons of cargo daily, regardless of the significant tidal range in Normandy, up to 20 feet. Offer protection from the elements, creating a sheltered inner harbor from the ravages of channel storms. From the outset, the design phase brought together the brightest minds in British engineering and naval architecture. Figures like the civil engineer JFT John Travers were instrumental in conceptualizing the enormous concrete structures that would form the backbone of the harbors. Numerous smaller, yet equally ingenious, components would also be needed, from floating roadways to specialized mooring dolphins. The decision to proceed with Mulberry was a massive gamble. The resources required, steel, concrete, manpower, and towing vessels, were immense, diverting critical assets from other wartime efforts. Failure would be catastrophic, not just in terms of wasted resources, but in jeopardizing the entire D-Day invasion. However, the alternative was considered even more perilous. The logistical iron law had to be broken, and Mulberry harbors represented the only truly viable path to achieving the sustained supply necessary for the liberation of Europe. The spark of genius had ignited an impossible project, shrouded in secrecy, that aimed to build a new chapter in military history, literally from the ground up, or rather, from the waves up. The directive to build our own ports set in motion an extraordinary design and manufacturing challenge, resulting in a collection of components that were individually ingenious and collectively revolutionary. The Mulberry harbors were not single structures, but complex systems composed of several distinct, prefabricated elements, each meticulously designed to perform a specific function in creating a functional harbor out of an open beach. At the heart of the harbor's protection lay the colossal Phoenix caissons. These were immense, hollow concrete blocks, varying in size, with the largest being the size of a 5-story building and weighing over 6,000 tons. Constructed in dry docks across Britain, these gargantuan structures were designed to be towed across the channel and then deliberately sunk in lines, forming massive offshore breakwaters. Their sheer bulk would dissipate the force of waves and tides, creating a sheltered, calm inner harbor where cargo ships could safely unload, a vital necessity on the exposed Normandy coast. The visual spectacle of these enormous concrete behemoths being built and then towed was a testament to the unprecedented scale of the project. Complementing the Phoenix caissons were other, smaller floating breakwaters. The bombardon units were cruciform, cross-shaped, steel structures, some 200 feet long, designed to absorb wave energy. They were floated out to sea and formed an outer ring of defense, further calming the waters before they reached the inner breakwaters. When weather made towing impossible, obsolete merchant ships, known as gooseberry block ships, were also scuttled to provide immediate, if limited, shelter closer to shore. Once a sheltered area was established, the next challenge was how to get supplies from deep-sea cargo ships to the beach, especially given Normandy's significant tidal range. The solution came in the form of innovative floating roadways and pier heads. The floating roadways, code-named Whale, were a marvel of modular construction. These were sections of steel bridging, each 80 foot long, mounted on floating pontoons. These pontoons allowed the roadway to rise and fall with the tide, maintaining a constant level with the pier heads. Whales were towed in long, serpentine sections across the channel and then linked together to form continuous roads stretching from the offshore piers to the beach. They provided a robust, all-weather link for vehicle traffic, directly from ship to shore. Connecting the Whale roadways to the deep-water cargo ships were the spud pierheads. These were large, self-contained floating platforms, each equipped with 4 retractable legs, or spuds. Once positioned, these spuds would be lowered to the seabed, effectively anchoring the pierhead and creating a stable, fixed platform. As the tide changed, the pierhead would float up and down, but its legs would slide through guide sleeves, keeping the platform level and steady. Each pier head included a crane and offloading equipment, making it a fully functional mini-dock capable of handling large cargo. The entire system was designed for efficiency, resilience, and rapid deployment. Components were manufactured in hundreds of locations across Britain, often disguised as other war production to maintain secrecy. The logistical feat of coordinating the production, assembly, and precise towing of these enormous and diverse elements, sometimes hundreds of miles across a hostile sea, was staggering. 2 full-scale Mulberry harbors were constructed: Mulberry, destined for Omaha Beach, American sector, and Mulberry, B, for Gold Beach, British sector. These weren't improvised structures, they were meticulously engineered, industrial-scale solutions to a strategic problem. The anatomy of the Mulberry harbors revealed a profound understanding of maritime engineering and the logistical demands of modern warfare. They embodied the Allied determination to overcome any obstacle, literal or metaphorical, ensuring that D-Day would not be crippled by the lack of conventional ports. The audacious design of the Mulberry harbors demanded a manufacturing effort of truly unprecedented scale and complexity, a testament to Allied industrial might and organizational genius. Across Britain, hundreds of thousands of workers, from engineers and welders to dock laborers, toiled in absolute secrecy to bring the components of these artificial ports to life. Dry docks that would normally construct battleships were now filled with dozens of Phoenix caissons, growing steadily into concrete giants. Steel fabrication yards churned out hundreds of whale roadway sections and bombarded breakwaters. Shipyards, already strained by the demands of conventional naval construction, found new capacity to produce the specialized spud pierheads and pontoons. The sheer volume of materials required was immense: hundreds of thousands of tons of concrete, tens of thousands of tons of steel, and countless hours of skilled labor. This colossal industrial undertaking had to be meticulously coordinated, ensuring that each component was completed on schedule and to precise specifications, ready for its critical role in the invasion. The logistical challenge of moving these enormous, often unwieldy structures from their various manufacturing sites to marshalling areas around the English coast, all while maintaining the utmost secrecy, was a feat in itself. Roads were temporarily closed, waterways adapted, and movements were often confined to night hours to prevent enemy reconnaissance from detecting the true scale of the preparations. Once manufactured, the most perilous phase began: towing the components across the English Channel. This was not a simple journey. The Phoenix caissons, once floated out of their dry docks, sat low in the water but still presented immense windage and drag. The whale roadways, long and articulated, snaked behind powerful tugs like giant serpents. The bombarding units and spud pierheads also had to be carefully managed. This armada of prefabricated port components, stretching for miles across the channel, began its slow, vulnerable journey under the cover of the D-Day invasion itself. The crossing was fraught with danger. The channel, even after the initial invasion, remained a treacherous waterway. German E-boats, motor torpedo boats, mines, and what remained of the Luftwaffe posed a constant threat. Moreover, the weather was always a factor. The very nature of the Mulberry designs meant they were vulnerable to heavy seas during transit. Each component had been carefully designed to withstand the channel, but an exceptionally violent storm could spell disaster, as would later be tragically proven. Upon arrival off the Normandy coast, the final, painstaking phase of assembly began. This was a monumental engineering feat performed under combat conditions. Precise positioning was paramount. The Phoenix caissons had to be carefully flooded and sunk into predetermined locations, forming the vast breakwaters. Teams of divers worked tirelessly beneath the waves, often in perilous conditions, to prepare the seabed and ensure the caissons settled correctly. The bombarding units were carefully linked to form the outer wave-dampening ring. Next came the intricate process of connecting the floating whale roadways to the spud pierheads, which had been accurately positioned and spudded down into the seabed. The roadway sections, each articulated to handle the tide, had to be carefully aligned and bolted together, creating continuous arteries for traffic. Cranes on the pierheads, operated by naval construction battalions, swung into action, offloading cargo directly from merchant ships onto the roadways, which then led straight to the beaches. The entire assembly process was a race against time, with the constant threat of enemy action and the unpredictable channel weather. The goal was to create fully functional harbors as quickly as possible, transforming an open, exposed stretch of sand into a bustling hub of logistical activity. This massive industrial leviathan, spanning the entire production and deployment cycle, was a testament to the Allied determination to overcome any obstacle, literal or metaphorical, that Hitler's Atlantic Wall could throw at them. The Mulberry harbors, once a spark of genius, were now tangible structures, ready to play their crucial role in fueling the liberation of Europe. With the colossal components of the Mulberry harbors manufactured and safely marshaled, the moment of truth arrived shortly after the D-Day landings. 2 full-scale artificial harbors were planned, each destined for a critical sector of the invasion beaches. Mulberry, for the American sector at Omaha Beach, and Mulberry B, for the British and Canadian sector at Gold Beach, off Arromanches. The success of the beach landings was only the first hurdle. Now, these instant ports had to come to life to ensure the invasion's survival. The deployment of Mulberry at Omaha Beach began with immense hope. Engineers and naval construction units worked frantically to assemble the massive floating breakwaters and pier heads. American ingenuity, combined with British designs, was put to the test under the most grueling conditions. For a few critical days, Mulberry began to function, proving the concept viable as vital supplies flowed onto the American beachhead. However, fate intervened with brutal force. Just 2 weeks after D-Day, on June 19, a colossal storm, one of the worst June gales in 40 years, swept across the English Channel. The exposed Mulberry, still largely incomplete and more vulnerable than its British counterpart, was utterly devastated. Phoenix caissons were ripped from their moorings, whale roadways buckled and broke, and spud pierheads were overwhelmed. The dream of Mulberry became a shattered ruin, a tragic loss of an immense engineering effort. The destruction of Mulberry was a devastating blow to Allied logistics, threatening to plunge the American sector into a critical supply crisis. However, the experience of Mulberry B offered a stark contrast and proved the resilience of the overall concept. Positioned off Gold Beach, Mulberry B, which would famously become Port Winston at Arromanches, was situated in a more sheltered bay and, crucially, had been more fully assembled by the time the devastating gale hit. While it sustained significant damage, the core structure largely held. The engineers, working against the clock and the elements, were able to quickly repair and reinforce the damaged sections. Within days of the storm subsiding, Mulberry B was fully operational, and its impact was immediate and profound. Deep-sea cargo ships, which had previously been forced to anchor miles offshore and unload via vulnerable landing craft, could now dock directly at the stable spud pierheads. Cargo was craned directly onto the whale roadways, which rose and fell with the tide, then transported directly onto the Normandy shore. This continuous, efficient flow of supplies was exactly what the invasion desperately needed. The sheer volume of material that poured through Mulberry B was staggering. Thousands of vehicles, hundreds of thousands of tons of ammunition, food, and general cargo, and crucially, immense quantities of fuel, began to flow ceaselessly onto the continent. This allowed the Allied armies to consolidate their beachhead, build up their forces, and prepare for the breakout from Normandy. Without this artificial port, the logistical bottleneck would have been catastrophic. The destruction of Mulberry highlighted the inherent risks, but the success and rapid recovery of Mulberry B validated the audacious vision. For German intelligence, the sudden appearance of these colossal structures off the Normandy coast, almost overnight, was a source of profound bewilderment. They had planned for beach landings and demolished ports. The idea of the Allies bringing their own ports was a concept that had not been taken seriously, or even conceived of, in their pre-invasion analyses. Aerial reconnaissance reports of massive concrete blocks and floating roadways must have seemed fantastical. While the destruction of Mulberry undoubtedly brought a fleeting sense of relief and vindication to the German command, the continued operation and immense capacity of Mulberry B quickly turned their relief into growing confusion. They were witnessing logistical capabilities that simply defied their understanding of military convention and engineering possibility. The Allies had literally reshaped the battlefield, creating a logistical lifeline where Hitler had been certain there could be none. With Mulberry B at Arromanches fully operational and proving its resilience, the logistical bottleneck that had once haunted Allied planners and reassured German intelligence was effectively broken. Port Winston, as Mulberry B became affectionately known, became the pulsing heart of the Allied supply effort, a marvel of wartime ingenuity pouring the lifeblood of material onto the continent. The scale of its contribution was immense. 4 months, Mulberry B. offloaded an average of 6,000 tons of supplies every single day. At its peak, it handled up to 9,000 tons in a 24-hour period, a volume that rivaled many conventional ports. From D-Day until it was decommissioned in November 1944, over 2.5 million men, 500,000 vehicles, and 4 million tons of supplies were brought ashore via the Mulberry harbors, primarily Mulberry B, after the loss of A. This torrent of supplies included everything from ammunition and spare parts to food, medical equipment, and, crucially, vast quantities of fuel. This continuous and efficient flow of material was the critical enabler for the success of the Normandy campaign. It allowed the Allied forces, initially confined to a relatively small beachhead, to rapidly build up their strength, replace losses, and prepare for the decisive breakout operations. Without the capacity provided by Mulberry B, the sheer number of troops and quantity of equipment required to launch operations like Cobra, the American breakout, and Goodwood, the British armored offensive, would have been impossible to sustain. The artificial port granted the Allied generals the freedom to launch aggressive, large-scale offensives, knowing their armies would be constantly replenished. The impact was particularly felt as the Allied armies finally broke out of the Normandy hedgerows in late July and early August. Forces, especially fast-moving armored divisions like George S. Patton's Third Army, launched audacious thrusts across France. These lightning advances, characterized by high-speed movement and deep penetration, were extraordinarily fuel-intensive. While projects like Pluto, pipelines under the ocean, provided bulk fuel, Mulberry B was simultaneously handling a diverse range of supplies, including crated fuel, spare parts for tanks and trucks, and heavy equipment that kept the entire mechanized force in motion. The combination of these logistical innovations ensured that the momentum, once gained, was never lost. For the German High Command, the sustained and increasingly rapid Allied advance continued to be a source of profound and exasperating bewilderment. Their initial confidence in the iron law of logistics had been utterly shattered. They had seen reports of ports destroyed, they understood the immense challenges of open beach offloading, and yet, the Allied armies did not stop. Hitler himself, and many of his generals, could not fathom how such an immense force was being so continuously supplied. They searched for conventional explanations: massive, undetected road convoys? Secretly repaired port facilities? None fully explained the scale of the logistical achievement. The truth, that the Allies had simply brought their own ports with them, was often dismissed as fantastical or remained largely outside their realm of serious consideration. Even with aerial reconnaissance observing the huge structures off Arromanches, the full strategic implications and the sheer operational effectiveness of Mulberry B were underestimated. The Germans continued to fight a war based on outdated logistical assumptions, while the Allies waged a war of unprecedented engineering and supply. Mulberry B was not just a marvel of construction. It was a symbol of strategic foresight and a testament to the fact that ingenuity, even on the mundane front of logistics, could literally reshape the course of the war, enabling the liberation of an entire continent. The colossal storm of June 19, 1944, which utterly decimated Mulberry at Omaha Beach, served as a stark and brutal reminder of the unforgiving nature of the English Channel. It was a weather event that, by all rights, should have crippled the entire artificial harbor concept. Indeed, the loss of Mulberry was a devastating setback, costing immense resources and forcing the American sector to scramble for emergency supply solutions, relying heavily on direct beach offloading and, eventually, a partially repaired Cherbourg. Yet, the very same storm inadvertently solidified the triumph and proved the remarkable resilience of Mulberry B at Arromanches, which would earn its lasting nickname, Port Winston. Mulberry B, located in a more naturally sheltered bay and having been more thoroughly constructed by the time the gale hit, largely weathered the tempest. While it sustained significant damage, including some sections of the floating roadways being ripped away and a few phoenix caissons being dislodged, the core structure of its breakwaters held firm. The damage, though serious, was reparable. This critical distinction allowed engineers and naval construction units to work ceaselessly, often under harrowing conditions, to to quickly restore full functionality to Port Winston. The experience highlighted the wisdom of selecting varied sites and the inherent robustness of the design. The survival and rapid recovery of Mulberry B allowed it to pick up the slack from the lost American harbor. From that point on, Mulberry B became the primary artificial port, a singular conduit for the immense flow of supplies needed for the entire Allied front. Its continuous operation, despite subsequent smaller storms and the inherent wear and tear of wartime use, was a testament to the quality of its engineering and the dedication of the thousands of men who operated and maintained it. Divers constantly inspected the caissons, engineers managed the complex floating roadways, and naval crews ensured the steady flow of merchant shipping. The scale of its endurance was truly remarkable. Despite being a temporary wartime expedient, Mulberry B continued to function for over 5 months, well beyond its initial projected lifespan. It was intended to bridge the gap until conventional ports could be captured and repaired, but its reliability and capacity far exceeded initial expectations. It handled cargo until late November 1944, by which time major ports like Antwerp had been captured and made operational, and Pluto was beginning to take on an even larger share of fuel delivery. For German intelligence, the continued, robust operation of Port Winston compounded their bewilderment. They had documented the destruction of Mulberry, surely offering them a fleeting sense of vindication for their predictions about the impossibility of such ventures. However, the undaunted functioning of Mulberry B meant that their core assumption that the Allies would fail for lack of ports remained fundamentally flawed. They continued to observe its activity through aerial reconnaissance, noting the constant stream of ships and supplies, yet the sheer audacity and effectiveness of the concept remained largely beyond their comprehension. It was one thing to spot concrete blocks. It was another to grasp the strategic implication that an entire logistical lifeline had been conjured from the sea. The endurance of Mulberry B was a psychological blow to the German command. It proved, unequivocally, that Allied ingenuity could overcome even the most fundamental geographical and logistical barriers. It denied them the anticipated breathing room to reorganize and counterattack, instead providing the relentless flood of resources that pushed their forces further and further back. Port Winston stood as a concrete symbol of Allied determination, a silent, unyielding monument to their ability to adapt, innovate, and conquer, effectively turning the channel itself into a logistical highway that Hitler had believed impassable. The Allied success in solving the D-Day logistical riddle was not just an operational triumph. It was a profound intelligence victory that plunged the German High Command into a state of continuous, agonizing bewilderment. Hitler and his generals had staked their defensive strategy on the certainty that the Allies would eventually grind to a halt without functional deep-water ports. Yet, as the invasion progressed and the Allied armies maintained a relentless pace, consuming vast amounts of supplies, this fundamental assumption crumbled, leaving German intelligence strategically paralyzed. Their aerial reconnaissance observed the massive structures off Arromanches, the surviving Mulberry B, confirming the presence of an artificial harbor. While the initial reports might have been dismissed as fantastical, the undeniable reality of ships offloading at Port Winston forced a grudging acknowledgement of the engineering feat. However, even then, the full scale of its contribution and the Allied capability to operate it effectively under wartime conditions were consistently underestimated. The Germans struggled to integrate such an unconventional solution into their traditional military assessments, often downplaying its efficiency or believing it would soon succumb to channel storms or sabotage. But the confusion was compounded by another, equally baffling phenomenon: the seemingly inexhaustible supply of fuel. Even if Mulberry B was handling general cargo, the sheer volume of gasoline, diesel, and aviation fuel pouring into the Allied war machine seemed to defy all conventional means of delivery. German intelligence diligently searched for massive convoys of tanker ships, but their numbers seemed insufficient. They looked for vast fuel dumps built up behind the beaches, but these were either too well camouflaged or simply not large enough to explain the consumption rates. They theorized about hidden oil wells, unprecedented rationing, or even a sudden miraculous discovery of fuel sources in liberated France. This profound logistical blind spot was a direct result of the success of Project Pluto, pipelines under the ocean. While the massive concrete structures of Mulberry B were at least visible from the air, the flexible pipelines snaking across the seabed were almost entirely undetectable. German naval intelligence never confirmed the existence of Pluto during the war. Any isolated sightings of cable-laying ships were likely dismissed as routine communications work, or the pipe itself mistaken for a telegraph cable. The concept of an underwater fuel pipeline system was simply too far outside their intelligence parameters and technical imagination. The combined effect of Mulberry harbors and Pluto created a double blind that profoundly impacted German strategic decision-making. They faced a logistical nightmare they couldn't comprehend, let alone counter. If they had known the full scope of both projects, they would undoubtedly have diverted significant resources, U-boats, E-boats, sabotage units, and long-range aircraft, to attack these critical supply lines. Yet, because the true mechanisms of Allied supply remained largely secret or dismissed as impossible, these crucial assets were often deployed elsewhere, squandered on less vital targets, or held in reserve for phantom threats. Hitler's repeated questions to his generals about the Allied fuel supply underscore the depth of their confusion. His belief that the logistical iron law would save Germany persisted, even as the evidence on the ground increasingly contradicted it. This fatal oversight was a testament to the power of Allied ingenuity and deception, which exploited German preconceptions and rigidity of thought. The enemy was left fighting a ghost in the supply chain, unable to target the very arteries that sustained the invasion. The secret of the Mulberry harbors and Pluto provided a continuous, silent stream of resources, baffling German intelligence and preventing them from disrupting the essential lifeline that secured the Allied victory in Europe. The triumph of the Mulberry harbors, particularly Mulberry B at Arromanches, represents one of the most extraordinary and often unsung achievements of World War II. It was a victory not of firepower, but of ingenuity, industrial might, and a relentless determination to overcome seemingly insurmountable logistical obstacles. By literally bringing their own ports to the invasion, the Allies defied centuries of military doctrine and shattered Hitler's core assumption that a successful, sustained invasion of Europe was impossible without captured deep-water facilities. The impact of the Mulberry harbors on the D-Day landings and the subsequent liberation of Europe was nothing short of monumental. They provided the crucial throughput capacity during the critical initial months of the invasion, bridging the immense gap between beach landings and the eventual availability of fully functional continental ports. Without Mulberry B, the buildup of forces, vehicles, and essential supplies would have been drastically slower, leaving the Allied armies vulnerable and potentially stifling the momentum of the breakout from Normandy. It ensured that the strategic initiative, hard won on the beaches, was never relinquished due to a lack of vital resources. The story of the Mulberry harbors is a powerful testament to the thousands of engineers, designers, factory workers, and naval crews who toiled in secrecy and under immense pressure. It was a project that pushed the boundaries of civil and maritime engineering, adapting existing technologies and inventing entirely new ones to meet an unprecedented challenge. The Phoenix caissons, the whale roadways, and the spud pierheads were not just pieces of military equipment, they were monuments to human problem-solving, designed to conquer the unforgiving forces of the Channel and the tidal range of Normandy. For German intelligence, the Mulberry harbors, alongside Project Pluto, served as a continuous source of frustration and strategic paralysis. Their inability to fully comprehend or counter these audacious logistical innovations highlighted a fundamental blind spot in their military thinking. They had correctly identified Allied logistical vulnerability, but utterly failed to predict the Allied capacity for radical, large-scale engineering solutions. This underestimation of Allied ingenuity directly contributed to their strategic miscalculations and their inability to effectively disrupt the supply lines that ultimately sealed their fate. The legacy of the Mulberry harbors extends far beyond their operational lifespan in 1944. They proved the feasibility of artificial port construction, influencing future military and civil engineering projects. More importantly, they stand as a potent symbol of the Allied approach to total war, a holistic strategy that integrated battlefield courage with scientific research, industrial capacity, and logistical genius. Victory was not determined by a single wonder weapon, but by the ability to orchestrate a vast, interconnected system of innovation and supply. Today, fragments of the Mulberry harbors still remain off the coast of Arromanches, visible at low tide, silent, concrete witnesses to an extraordinary chapter in history. They serve as a poignant reminder of the sheer scale of the D-Day achievement and the ingenuity that went into sustaining it. Hitler thought D-Day would fail without ports, believing in the iron law of logistics. But the Allies, through a breathtaking act of engineering and will, simply built their own, forging a lifeline from the Channel itself and ensuring the relentless, fuel-driven advance that led to the liberation of Europe. The instant ports were a quiet triumph, a testament to the fact that, in the face of impossible odds, human creativity can truly reshape the world.